In this lesson, I'm having students multiply binomials or polynomials and look at special patterns that are formed from multiplying some binomials. And so we have a sum and difference of identical terms in the first one, x minus 2 times x plus 2. So that should form a difference of squares. And so students are just looking at this pattern, and we can see that when you multiply x times x and distribute the x to both terms, and then plus x times 2, and then minus 2 times the x, distribute the negative 2 to both terms in the second parentheses, and negative 2 times 2, you get x squared plus 2x minus 2x. So you can see that those middle terms go to 0, and you're just left with x squared minus 4, which is a difference, perfect squares on each side of a subtraction sign, which was difference of squares. And then we'll look at the formula more when we get to the patterns and the partner activity. I'm just mainly focused on, do you recognize a pattern that's happening with these? And they may not till they see it repeatedly throughout the lesson. X plus 5 squared, when you expand that, students need to recognize that they can expand it out and not make the mistake of saying that this is x squared plus 25, but expand it out because there is a middle term that does not go to 0 when you square binomials, identical binomials, x plus 5 times x plus 5. So you would have x times x plus x times 5, and then when you distribute the second one to both parentheses, you'd have positive 5 times x and positive 5 times 5. And so you end up with a perfect square trinomial, x squared plus 10x when you add 5x and 5x plus 25, and as you can see, this is the 5 being squared here, this is the x being squared, and this is positive 2 times x times 5, which is the 10x, and we'll talk about that pattern more with students as being a squared plus 2ab plus b squared in the partner activity. X minus 3 squared, if you expand that out, you end up with the same thing except for a minus to multiply the a times b. So x minus 3 times x minus 3. Make sure they don't make the common mistake of x squared minus 9 and just squaring both terms without expanding it out because they missed the middle term. So you end up with x squared minus 3x minus 3x for the middle term there, and minus 3x ends up with negative 6x, and then positive 9 for the b squared, which is your 3. And we'll talk about, well, that's just x being squared, that's your a term, your 3's being squared, that's your b term, and again you end up with 2 times a, which was x, times b, which is 3, and you can see that that creates negative 6x. So we'll talk about that pattern more. X minus 2 to the third, they can use the x minus 2 squared first, their knowledge of that, and realize that that's a perfect square trinomial of x squared minus 2x, and 2x is going to make the negative 4x, and then plus 4, and that still is recognizing as a perfect square trinomial, your x being squared, and then your 2 times x times 2, and then your 2 being squared for your b squared term. But in this case you have to multiply it again times x minus 2, and so they have to realize they're distributing the x to all 3 terms this time in the other parentheses, and then the negative 2 to all 3 terms in the second parentheses. And then they have to simplify and combine like terms. And the last one in the introduction that you don't see on this page is just different binomials that are being multiplied, and it just shows that it forms a trinomial that is not a perfect square trinomial. It just ends up being a trinomial.